Welcome to a Research Sensors video. In this case, we will talk about inductive, capacitive, photoelectric, and ultrasonic sensors. The inductive sensor registers a contact to an inserted object without touching it. The sensor has an active surface called oscillator on its front, and this generates an electromagnetic field with a semicircle shape. When a metal object is near the detection zone, the electromagnetic field will decrease its strength, and this allows the sensor to detect how far the object is. The functioning of a capacitive sensor uses the principle of an ideal plate capacitor. As we know, a capacitor consists of two plates. One is the surface of the sensor, and the other plate is the object that we would like to sense, which lies across from it. An electrical field is generated between the plates, in this case the object and the sensor, and a kind of a protection ring around the device structure ensures that the electrical field is homogeneous as possible. If an object enters the field, the distance between the plates changes, and this distance can be measured. The ultrasonic sensor measures the distance through the ultrasonic waves generated. The head sensor emits the ultrasonic wave, and it receives the reflected wave that returns because of the object that we want to sense. The distance can be measured counting the time between the emission and the reception of the sound. In addition to that, the ultrasonic sensor has a unique head that works as an emitter and receptor. The photoelectric sensors work under the same principle, which consists in emitting a light that can be seen with human eyes and then receiving it backwards. There are three types of configuration or photoelectric sensors. The first one taken in consideration is the diffuse reflective sensor. This sensor has an emitter and a receiver, so when the light is reflected, the receiver detects the light. On the through beam sensor type, the light of the emitter is constantly received by the receptor. So when an object interrupts the path of the emitted light, the receptor senses that there is an object. At last but not least, the retroreflective configuration needs a reflector, and the light incites this reflector constantly. When an object interrupts the light path, a signal is created.
What kinds of materials and range detect each sensor? The inductive sensor. The sensing range of an inductive switch is dependent on the type of metal being detected. Ferrous metals, such as iron and steel, allow for a longer sensing range, while non-ferrous metals, such as aluminum and copper, may reduce the sensing range up by to 60%. A capacitive sensor. A typical sensing range for a capacitive proximity sensor is from a few millimeters up to about 1 inch. And some sensors have an extended range up to 2 inches. Some examples of the solid materials a capacitive sensor can detect are all types of metal, all types of plastic, wood, paper, glass, and cloth. Capacitive sensors can also detect liquids, water, oil, and paint. The photoelectric sensor. These sensors can operate on the principle that an object interrupts or reflects light, so they are not limited like proximity sensors to detecting metal objects. This means they can be used to detect virtually any object, including glass, plastic, wood, and liquid. The sensing distance can range from 10 to 35 millimeters depending on the upper and lower limits. An ultrasonic sensor. The ultrasonic sensors can detect a wide range of material, hard, soft, any color, flat, or curved. They can also reflect off transparent objects such as glass or a liquid surface, and are stable for targets such as mesh trays or springs. Ultrasonic sensors are suitable for close range detection up to 10 meters and provide multiple range measurements per second.
Now we are going to present some applications of these sensors. The most common application of the inductive sensors is as a proximity sensor, and it is key in automation nowadays. One of its applications is to detect position of a mechanical moving part. Thanks to its precision, it helps to detect motion and ensure accurate positioning. Also, it could be used on packaging lines of canned products. Some capacitive sensors can be used to detect material inside a non-metallic container, usually liquids. This is possible adjusting the sensing range these sensors have. Another application is the measurement of brake disc deformation in cars. Some capacitive sensors have great resistance to temperature changes. Photoelectric sensors have many applications. One of them is checking objects on production lines to detect sizes, absence, or spot errors in the products. A very common application is on automatic doors used in public transport, buildings, or elevators. Some common applications of the ultrasonic sensors are proximity detection and ranging measurement. This sensor can be used to control liquid levels in containers. Also, anti-collision detection can be another application used in cars.
What is the cable color code used in the sensor bracing? To connect each sensor is in the following ways. For inductive sensor, brown wire connect to 24 volts, and blue wire connect to ground, black wire connect to terminal A2 of the relay, and A1 of the relay is connected to ground. For the capacitive sensor, brown wire connect to 24 volts, blue wire connect to ground, white wire connect to terminal A1 of the relay, and A2 of the relay is connected to ground. For photoelectric sensor, brown wire connect to 24 volts, blue wire connect to ground, white wire connect to terminal A2 of the relay, A1 of the relay is connect to ground, and black wire connect to ground. And the last sensor is ultrasonic sensor. Brown wire connect to 24 volts, blue wire connect to ground, black wire connects to terminal A2 of the relay, and A1 of the relay is connect to ground. Only that.
To keep up with the presentation, I'm going to explain what an NPN and a PNP transistor output is. Now, while both have the ability to amplify signal or even act to switch larger currents on and off, they accomplish this signal boosting ability in different ways. The first one, the NPN transistor output, amplifies a positive signal applied to the base by allowing a larger current to flow from the collector to emitter pins of the device, proportional to the base voltage. Now the next one, the PNP transistor output, performs the same job but is set up so that a negative voltage must be applied to the base pin to allow current to flow from the emitter to the collector lead.